our normal model for proportions?
Random.
It's gotta be random. It's just a random sample.
Yes.
Got it.
Yes, sir.
Is 250 students polled? Less than 10% of all upperclassmen students in Iowa.
Yes.
I hope so. So each sample is independent because it's not a big enough proportion of the entire population. Now let's check the success-failure condition. I need to expect in my sample of 250 at least 10 students that felt like they were prepared and 10 students that didn't. So take the sample size 250 times both P and Q to tell you how many students to expect that fall into each of our two categories. They're both more than what? 10. I have at least 10 successes and 10 failures. That condition helps to make sure that your P and Q values aren't super close to either 0 and 1. I have a representative sample, a part of each of our two categories. So based off of these conditions having been met, we can assume a normal model applies, and later in step 4, we can use a z-score. Part 2, let's do the hypotheses. This is an important step because it kind of frames the rest of your hypothesis. What's our ho and ha? What'd you guys write? No one alternative hypothesis.
E is equal to 28%.
So let's assume there is no difference. The status quo. Here in Iowa, we still have approximately 28% of students that felt like they were adequately prepared for life post-graduation. What else? For alternative.
Not equal to that.
What told you that then, Kyle?
It is different.
Different means the proportion could have increased, could have decreased, could have gotten bigger for students feeling they're prepared, could have gotten smaller for students feeling they're prepared. It just can no longer be the same as 28%, right? It could have gone in either direction, more students or less students, just not the same as was previous before. Questions so far? Let's do a rejection region. Is this a 1 or 2-tailed test? Why do you know it's 2?
Different.
It's different. Different means it could have gotten bigger or smaller, right? It could have gotten more extreme in either direction. So put some of our 2% error in each of the 2 tails. When I outline my rejection region, I know it's a 2-tail hypothesis test. What percent goes in either tail if I have an error probability of 2%? 1%. With the other 98% being put in the middle. Since you've got all those nice z-scores on your formula sheet, which one do I need? 232.6, right? 2% error level, 2-tail hypothesis test, uses z-score of approximately plus or minus 2326. So for the upper tail, it's the positives. And for the lower tail, you make it negative. One way to find our correct decision on a hypothesis test is to, in the next step, calculate the test statistic. If it falls in one of these rejection regions, I know I have significant results. If a test statistic is more extreme, further from 0 than plus or minus 2.326, we can reject the null hypothesis and I have significant results. Let's get that test statistic. On the back page, z-test for one proportion. We're taking a sample and recording one proportion of the population. So our test statistic, our z-score, is p hat minus p. Divided by the square root of p times q over n. We've already got all that information up here, so let's find that out. P hat minus p is 60 over 250 minus 28% divided by the square root of 28%. Excuse me, 72% divided by 250. Did you guys get this typed into your calculator? Negative 141. All right, let's check that here. Make sure we all got it. 60 out of 250 minus 28%. The difference in the two proportions divided by the standard deviation to convert it to a z-score. 28%. 2% divided by 250. Yeah, I agree. Negative 141. Where would that fall in my distribution? Is it in the tails or is it in the middle somewhere? Is it more extreme, further from zero, our z-score based off our sample? Is it more extreme than plus or minus 232.6? No. Oh, isn't it kind of right here?
Yes.
So in a minute, when I make the decision, what should our decision be? Fail to reject, because my z-score is not more extreme than the rejection region z-scores, the critical z-scores we put together here a minute ago. You can reach the decision one of two ways: by comparing your test statistic with the critical z-scores in the rejection region, or by comparing your p-value, we're going to look up in a minute, to your significance level. Put this over here. Step 5 is the p-value. Grab your z-table. Let's look up the probability of a z-score of negative 1.41. Negative 1.41. I want the probability of a z-score more extreme than that. So z-score less than or equal to negative 1.41. What do you get? I got 0793. Here's the trick. This is where almost everybody makes a mistake when they first start doing hypothesis tests. How many tails are there? This is a what type of hypothesis test? 2 tails, right? We know the proportion that falls into the left tail. When I also need to know the proportion that goes in the right tail, since it's a 2-tail hypothesis test, it could be more extreme in either direction. The proportion of students that felt prepared could either change by getting smaller or getting larger. I only know the proportion that decreased in the left tail. I want the other tail too. So what do I have to do to that p-value? Just 1 minute. If I know the left tail, how do I also find the probability for the right tail? That's 7.93%. I also want to find the chance that it got more extreme in the other direction by increasing. Wouldn't it just be the same proportion, but on the other side? Yeah. Because the z distribution is symmetrical. So what could I do? If there's 7.93% that falls to the left, to the right would be another 7.93%. So to find the p-value, I have to double it. It could get more extreme in either direction. We looked up the part to the left. I also need to account for the right. The proportion of students is different. It could have gotten smaller or bigger. This is a 2-tail test, so you double the p-value. Get more extreme in either direction. The p-value is 2 times 0.0793. It's a 1-tail test. Leave it the way it is off your z-table. It's a 2-tail test. You have to double it. Because it could get more extreme. Students could change in either direction. By feeling more prepared or less prepared. What is 2 times 7.93%? 1586. Got it. What does that p-value mean? Back here to my definition. I'm going to ask you this definition on your next quiz. The p-value of a hypothesis test is the probability of seeing a sample such as mine, my sample of students, or a sample more extreme if the null hypothesis was true. If it's actually true that 28% of students in Iowa felt prepared for life after high school, I would find my 60 students in a sample of 250 approximately 16% of the time. If the null hypothesis were true, it's actually true that 28% of students felt prepared for life after graduation. I'd see sample data, such as mine, about 16% of the time. I can only reject the null hypothesis that's true 2% of the time. I only want to make a type 1 error 2% of the time. So what's our decision? Is P less than my significance level or greater than my significance? Greater. P is low, reject the ho. But if it's not, we have to fail to reject. That was the same decision you made by looking at our sample statistic of negative 1.41 for Z with the rejection region here, right? Didn't we kind of say the same thing? Because my Z score is not more extreme than plus or minus 2.326, I failed to reject. Similarly, because my p-value is greater than my significance level, I can only reject the null hypothesis that's true 2% of the time. This is not within that allotted error. I also have to fail to reject. So there's your decision. Let's talk one more thing about your conclusion. Let me go back to my courtroom example that we looked at when we did standard 20. We talked about hypothesis method. When the jury comes back with the verdict, they say one of two things. We find the defendants guilty, or what else? Not guilty. They wouldn't say we find the defendant innocent, would they? We're going to say something similar. Your conclusion shouldn't be 28% of students in Iowa feel like they're adequately prepared for college. We say we lack the evidence to say that different than 28% of students in Iowa feel like they're prepared for life after high school. I'm not trying to prove the null hypothesis. I'm trying to prove the alternative. I can't do it based off my sample data. So my decision and conclusion should be fail to reject the null hypothesis, and we lack evidence to say otherwise. We lack evidence to show that different than 28% of students in Iowa felt like they're adequately prepared for life after high school. You don't find the defendant innocent, you find the defendant not guilty. We failed to convict because of lack of evidence. We failed to show differently based off of our sample. So let's say we lack evidence to suggest that different 28% of students in Iowa feel like they're prepared. For post-graduation, life post-graduation. Here's how I kind of remember. Your decision's always in terms of the null hypothesis. Your conclusion's always in terms of the alternative. You either have the evidence to show that there is a difference, or you don't. In our case, since we failed to reject the null, we lacked proper evidence to suggest that there is a difference between the 28% national statistic and what we have here. any difference between these two proportions, any difference between the 28% national statistic and ours here in Iowa is just due to random sampling variability. I just found a random 60 students by chance that were different than the 28% national average. Insignificant data. We'll do some more work with this next week. Those juniors who did not get their quiz done on notation and type 1 or 2 errors, if you have some time later this morning or this afternoon after school's out, you want to get that done, that'd be great. Otherwise, we'll see you around. See you next week. See you Monday.
Do you have like I can just take it during like 6 hours?
Maddox, leave my friend alone.
We're just